Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of solving systems of equations. This is standard A.5C in the great state of Texas, and we are using item number 52 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we're looking for the x value of the solution. So we've got two different equations here, and they're in a system, which means they're sharing an x and y variable. So if we were to graph this, right, and somehow find where these two cross, and I've got no idea where it is, we're looking for, of that coordinate right there, we're looking for the x value. That's what that means when we're looking for the x value of the solution. Where's one x and y value that satisfies both equations? Well, we got two different options here, and you know what it looks like? This is really set up for substitution. Substitution is when you solve for one variable and then you substitute it into the other one. And look, they've already given us what x equals this 2y. So what I'm going to do is I'm just going to write this 7, and in place of this x right here, since it's a system of equations, I'm going to replace it with this 2y minus 4. So 7, 2y minus 4 plus 5y equals negative 66. Well, look, now I've eliminated x. I'm going to need that x back, but we can easily plug our y value into the first equation and get that. So I'm looking for an opportunity here to first distribute this out because I want to combine like terms. So this is going to be 14y minus 28 plus 5y equals negative 66. So now I can combine like terms. I got 14 and 5. I've got 19y minus 28 equals negative 66. So now I need to add 28 to both sides. It's going to start isolating this y, even though it's still 19y, right? I got negative 66 plus that positive 28. So let me see. That's going to get me negative 38. And so divide both sides. Let's see. Let's divide both sides by 19. And that's going to get me pretty simple, y equals 2. Now, that's not what I'm looking for here. First off, that's a negative 2. But secondly, I'm not looking for y, I'm looking for x. But what I am going to do is I'm going to plug this 2 back into, let's try this first equation. Y equals 2, and then 2 minus 4. And you know what? That is a negative 2. That's going to make a big difference there. So x equals negative 4 minus 4. So x equals negative 8. So there's that negative 2 that they're trying to trick us with. So it looks like my answer is going to be negative 8. But that's, if it's a system of equations, it's going to work for both. So let's see what happens if I substitute in for that second one. So 7x plus 5, and then that y is going to be negative 2. So theoretically, I plug this in, right? And I also get x equals negative 8. That's what I'm looking for. So 7x is going to be a minus 10 equals that negative 66. Let's add 10 to both sides. 7x equals, and now that's going to be negative 56. And hopefully you see where this is going right here, right? Divide both sides by 7. X also equals negative 8. Now that's the substitution method. If we wanted to, we could have done the elimination method, but it would have taken a little bit more work. What we do is we get both of these into standard form, right? So we would need to do x minus 2y. We'd have to move that over, equals negative 4. And then 7x plus 5y equals negative 66. We'd have to find a way, like maybe multiplying the top by negative 7. It's just too much work. So our answer here is H.